as I already told you, okay, we always begin by filling the electron configuration from this point right here. And just remember that S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. So, first of all, what I do is I need to build the electron configuration, the full electron configuration. So I'm gonna do it here. So I'm going to start with this point. I follow the arrow and I find out that I have 1s2. Then I follow the arrow and I have 2s2. Continue and I go to 2p6. Okay. Until this moment, I know I have 10 electrons. So I'm going to put a mark right here. Okay. And then I continue. 3s2 and then 3p6 and then 4s2. So I say 2s2, sorry, 3s2, 3p6 and 4s2. And I should continue. Okay, I should continue. Until this moment, I have 20 electrons. So I'm gonna put a mark right here. And I continue filling the chart, the Christmas tree. Okay. Then I go with 3d10 and then 4p6 and 5s2. 3d10, 4p6, 5s2. Okay. So at here I have 30, 38, which means I need 10 more electrons. So at this point, as I told you, I have 38 electrons, which means I need 10 more. So I continue with my tree and I go to 4D, 4D10. Okay, so I'm going to put 4D10 because I need 10 electrons and I have already the 10. I'm not going to change this number. So with this, now I'm going to be able, that is the full notation, because if you add all these numbers, 2, 2, 6, 2, 6, 2, 10, 6, 2, 10, is going to give you the 48. Okay. Now, what comes next is drawing the arrows. You can do it in boxes, but making the boxes takes a while, okay? But you can do it. You can do boxes, or you can do lines. You can do it with boxes or just lines, okay? Right, sorry guys. um, Okay, I'm about to finish. Well, in the video it's quite nice because I already had printed my boxes, you know. But when you are working in your notebook, you can make the tiny boxes, but it takes a while if you do it. So we start filling the boxes. Because here I have two electrons, I'm gonna have two arrows inside a box. Okay? So it could be one arrow up and one arrow down. We always begin with the upward arrow, okay? Then the next one is again two arrows. You can make the arrows like I did here, or you can make them like this. Both are considered to be arrows. Now I think this one is easier if you make like that, okay? But both ways are correct. Here I need six. I need six arrows. So one up, two up, three up, and now down. One down, two down, third down. And I have the six arrows. For 3s2, two arrows. Now as you can see without the boxes, it also looks okay if you do it like that. Or you can do the full arrows like that, okay? I have my six arrows over there. For 4s2, the two arrows, 3d10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For p6, I need six arrows. One up, two, three up, and three down. 5s2, two arrows, one up, one down. And 4d10, again, the arrows, like that. One up, 5, and then downward. Now, what method do you prefer? Do you prefer the boxes or do you prefer the lines? A or B?
B.
I think B is easier. Now, this one looks a lot better, okay? But B also works. So I suggest you to use the one that you feel more comfortable with. I feel more comfortable with this one because that's the method I was taught when I was your age. So you will see me always doing this method, like A. But I know that it requires a lot of time. So B, it also works. It's going to be correct if you do it like that. Anyway, will be fine. So this is the full orbital configuration, okay? Orbital configuration. Now, what comes after? Right after, what we need, I didn't show it in the video because I was not explaining that specific topic, but what comes after is the number of electrons in the outermost level. What is the outermost level here? What is it?
5.
The 5. Yes, it is correct. The outermost level is 5, okay, because it's the greatest quantum number. So we say greatest quantum number, which is 5s2. And in that orbital, I have only two electrons. So this is my amount or my number of electrons in the outermost level. Okay, 2 electrons. Now, what comes after? One more thing that you need to know is that in the number of electrons, you can't have more than 8 electrons. If you have more than 8 electrons, you did wrong, okay? So, don't forget about this. Don't forget this. Never more than 8 electrons. Just don't forget. Now, what comes after? We need to make the ring structure and the Lewis structure. So, how many rings is cadmium going to have?
5.
It's gonna have 5 rings. Okay, so you will put the symbol surrounded by 5 rings, just like I have over there. Now, what comes after? We need to fill it with all the electrons. Okay. Okay. So in the first orbital, I have 2 electrons. So I'm just going to put the 2 electrons right here. In the second orbital, I have how many electrons?
8.
I have 8. Okay, 2 plus 6, that makes 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. In the third orbital, how many electrons I have?
18.
I have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, in the fourth orbital, in the fourth ring, in the fourth orbital, how many I'm gonna have?
18.
Again, 18. I have 2 plus 6, which makes 8, plus the last 10, which is 18. So another 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. There are just 2 sides. Sorry. I'm gonna do them again because I want them to be a little bit more organized. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Bueno, it's a little bit better. And now, the most important one, the last one. I have 2 electrons in the outermost level, so I'm gonna put them one in the top, remember, clockwise, so the next one comes here. So these are the 2 electrons in the outermost level. I'm gonna highlight them just for you to remember this. Because those are the 2 electrons that you will put in Lewis structure. So this is the ring structure, and then comes Lewis. Okay, it's not well written, but I'm gonna leave it there. So for Lewis, you're gonna need the symbol and the electrons in the outermost level. Okay, you have 2 electrons in the outermost level, 1 and 2. So those are the only electrons that you're gonna put. And voila, that's it. As you can see, this topic is quite simple. It requires a lot of work, but it's an easy work to do. Okay, and just remember that the orbitals, the boxes, can be replaced by single lines. Now, if, for example, um, let's just put another example, okay? If, for example, um, your configuration is, just imagine, 1s2, 2s2, and 2p5, for example. How are you gonna do the arrows? My arrows are gonna be, well, of course, it's gonna be one up and one down, one up and one down. In this case that I have just 5, remember, I always come I always begin with my upward arrows from left to right. So 1, 2, 3, and then my downward arrows that I'm gonna put them in a different color. Okay. So my downward arrows are 4 and 5. That's the way that you should represent the orbitals of this configuration. Now, I didn't even mention what element is this. Just by taking a look to the configuration, what element is that one? Can you tell?
Oxygen.
It is number 9. What element is in the position 9 of that periodic table?
Fluorine.
Fluorine. So this is the configuration of fluorine, okay? So just remember this, that in the case of having less than required, or less than the maximum required, you always start with the upward arrows from left to right, and then you continue downward. Now let's try another one. These are just random examples, okay? I'm not working with any specific example, any specific element. These are just random examples for you to get used to it. So let's say 1s2, 2s2, 2p6, 3s2, 3p6, okay? Then comes after 3s2, 3p6, 4s2 and 3d10, okay? So will be 4s2 and 3d10. But instead of 10, let's say that I have 7. So here, just here in the last one, from the 10 arrows, you're gonna have 1 up, 2 up, 3, 4, and 5 up. And then the arrows that come down until you get to 7. Number 6 and number 7. That's the way it should be done. The rest of the arrows are in the exact same way that we did before. But this one is the one that matters. This is the